Hey guys, today we're going to take a look at the intersection of three planes. So there are several possibilities here. In fact, there are 8. So we're going to look at each one fairly quickly, to be honest. First we're going to look at the possibilities where they do intersect. Okay. So the first possibility is that we have a unique solution. So this is where they all cross sort of at one point. Okay. So not sort of one point, at exactly one point. So this is our unique solution. Okay, so that's kind of the nicest one. But then we've got 3 possibilities where there are an infinite number of solutions. So we've got infinite solutions. And this is where they all cross and form a line here. Okay, infinite solutions. Okay, and so we'll call this type 1. Okay, type 1. There we go. Okay, and so that's it's going to make a line here. Okay. All right, our next one here. So this is where 2 of them are coincident planes. You can see one plane is on top of the other. So you've got 2 planes that exist in the same space, and then you've got a third plane that cuts through them. So this one will also give you a line. It also has infinite solutions. So infinite solutions. And we'll call this one type 2. This is our second type. And so this one is also a line, but I'll write it in blue because it's a difference. And I spelled line wrong. All right. And finally, the third possibility is that we have 3 planes, all of which are coincident. So infinite solutions again. Solutions. Okay, and so 1, 2, 3. We'll call this the third type. This one, they intersect in a plane. Okay. All right. So let's look at the 4 where there are no solutions. Okay. So first of all, we've got 3 planes, and they're all parallel and they're all distinct. So parallel and distinct. And distinct. Okay, and so there are no solutions. Now this next one, we call this one the H configuration. Configuration. Okay, because it makes kind of this, well, if we had a cross section, it would kind of look like that, right? So these 2, there's 2 points of intersection, but it's not all 3 crossing. So you got 2 planes crossing and 2 planes crossing, but never all 3 crossing at the same point. Okay? So there is no solution for that one as well. This next one, it's actually just called no solution type 3. So we'll say no solution type 3. Which I didn't even label the other types as 1, 2, but whatever. And so this is where you've got 2 planes that are coincident and another plane is parallel to those. Okay? And finally, the delta configuration. The delta configuration. And you can see it's called that because it makes sort of this triangle symbol, which is how we denote delta. So configuration. I'm just going to config. There we go. Okay, and again, you can see they do cross here and here and here, but it's only ever 2 planes. Okay, never all 3. All right, so how to find the intersection between 3 planes. So what you're going to do is you're going to work with this in its Cartesian equations. Okay, and you're going to find the points of intersection by attempting to solve. I say attempting because, of course, sometimes there is no solution, okay? Not because you can get halfway through and give up. So we're going to, so you're going to solve these equations formed by their Cartesian equations. And you're going to do it by using either substitution or elimination, okay? Now, unfortunately, there's so many types that I'm not actually, I'm not sure why I put that in brackets. Okay, there we go. There's so many types, I'm not actually going to walk you through any examples today. I'm going to have you try them and then I will have the solutions in class for you to look at and compare. Okay? All right, so let's go through them really quickly, though. So first of all, the unique solution. So this is where they intersect at a point, at a single point, I should say. Single point. Okay? The vectors in this case would not be coplanar. Okay? So in other words, you cannot create a plane using the normals to these planes. Okay? It would not create a two-dimensional space. So not coplanar. Coplanar. I'm not sure if that should be spelled with an E and an A, but that looks right. And the easiest way to tell this, of course, I say of course like it's obvious, it's not necessarily obvious, but the easiest way to tell this is to take the cross product of two of them and then take the dot product with the remaining one. If it does not equal 0, then you're golden, okay? So if you are to solve the system of equations, what you would get then is a unique solution. A unique solution. So in other words, you would just get x equals something, y equals something, z equals something. Very specific. You would actually get numbers for all three. Okay? All right, so that's case 1. Let's jump over to case 2. So, case 2. So this is where they intersected a line, okay? But they're not parallel planes. None of them are parallel. So the planes are not parallel. Not parallel. But their normal vectors are coplanar in this case. Okay? Which would mean n1 dot n2 cross n3 would equal 0. Okay? So the intersection in this case is a line. Okay? And the one scalar equation in this case would be a combination of the other two. A combination of the other two equations. Okay? So by solving the system, what we'll find is that we will express two variables in terms of the third one. Okay? Using two equations. Okay? So, number 3. We've got another infinite number of solutions. So this is where we had two that were coplanar and one intersecting them. So two planes are coincident. And the third plane is not parallel to the coincident planes. Okay? Two of the equations are equivalent. Okay? And the coefficients A, B, C, and D are proportional for these equations. Proportional. Okay? Let's see. So the intersection in this case would be a line. And you may express two variables in terms of the third using two non-equivalent equations. All right. So, number 4, the final possibility for there being a solution. This is where all three planes are coincident. Okay, so the coefficients A, B, C, and D are proportional. Okay, for all three equations. Okay, the intersection in this case is a plane. Okay, any point on one plane is also a point on the other two planes. Okay. So there we go. All right, so that's it for ones that do have solutions. Let's take a look at the ones that do not have solutions. So for all of the following cases, there is no solution for the system of equations, and thus there is no point of intersection. Okay? The system of equations is, you may remember, we called it incompatible. Incompatible. Okay? And what this means is when we solve it, it will give us a false statement. A false statement. Okay? And what I mean by that, we've seen this lots of times now, but what I mean by that is something like 0 equals 1 or something like that. Something that's obviously not true. Okay? So let's see. So, there are 3. So the first one is there are 3 parallel and distinct planes. 3 parallel and distinct. I just dotted my C. All right. So the coefficients A, B, and C are proportional in this case. No. But the coefficients A, B, C, and D, if we include that D, they are not proportional. Okay? That D is what's throwing us off there. Okay? That constant at the end. All right. So the next possibility is that we have ourselves an H configuration. So 2 of the planes are parallel and distinct. Okay. And then the third one is intersecting. Okay. The coefficients A, B, and C are proportional in this case. Proportional, but only for the 2 planes that are parallel. Okay? Not for that third one. All right, so we could have our no solution number 3. So this is where 3 planes are parallel. So 3 of them are parallel. But only 2 are coincident. Okay? So you can see our picture here. 2 of them are taking up the same space, and then you've got a third one parallel to that. So the coefficients for A, B, and C are proportional for all equations. All equations. But A, B, C, and D are proportional for only 2 of them. Okay? Finally, the last one, delta. Which sounds like the coolest of the configurations if you ask me. But anyway, the planes are not parallel in this case. Okay? The coefficients in A, B, and C are not proportional. Proportional. Okay? And the normal vectors in this case are coplanar. Coplanar. So in other words, and we've said this before, but if we took the normal of the first one, well, first we take 2 and 3, and we find the cross product, and then we take the dot product with the first one, it will give us 0. So that's it, okay? So I do want you to take a look and try those examples, and then we will take them up in class. So until next time, go Sabres.